Welcome to the world of Git Large File Storage or LFS. In this presentation, we'll explore how to effectively manage large files within Git repositories. Git LFS is an essential tool for developers, designers, and data scientists working with big files. It ensures version control without the bloat. Storing large files outside your Git repository leads to faster cloning and fetching, and provides a seamless version control workflow. Let's understand the problems associated with large files in Git. Git is not inherently designed to handle large files efficiently. When we add big files directly into a Git repository, several issues arise. First, the clone and fetch operations become very slow, making it difficult for team members to quickly get the latest version of the project. Second, the repository size balloons, consuming unnecessary storage space. Third, Git storage of binary files is inefficient, as it saves every version of the file, increasing the repository's size exponentially. Finally, bandwidth limitations become a pain point, especially when team members are in different geographic locations. Git stores the complete history of every file, which makes the repository heavy. In the illustration, you can see that files like video.mp4, dataset.csv, and images.zip makes the repository large. So, what exactly is Git LFS? Git Large File Storage, or LFS, is a Git extension designed to handle large files efficiently. Instead of storing the actual file content in Git, LFS replaces those large files with text pointers. These pointers are stored in Git, while the actual file contents are stored on a remote server. Now let's see the key points of Git LFS. It was developed by GitHub in 2015. It is an open source extension, and it is supported by major Git hosting services. Now let's dive into how Git LFS actually works. The first step is to install the Git LFS extension and initialize it in your repository using the commands git lfs install and git lfs install local. The second step is to specify which file types should be managed by Git LFS with the command git lfs track with the extension of the file. The third step is to add, commit, and push files as usual. Git LFS handles the large files automatically. To add the Git attributes file, use the command git add at git attributes, and to add and commit files, use the command git add file.psd, and git commit with a commit message, and then git push to the remote repository. Behind the scenes, Git LFS replaces large files with text pointers and uploads the actual content to the LFS server. Let's install Git LFS. For Windows and Mac OS, you can download the Git LFS installer from the official website at git-lfs.github.com. Run the installer and follow the instructions. To verify that Git LFS has installed correctly, use the command git lfs version. On Mac OS, you can also install Git LFS using Homebrew with the command brew install git-lfs. For Linux systems, use the package manager specific to your distribution. On Debian or Ubuntu, use the command sudo apt get install git-lfs. On Fedora, use the command sudo dnf install git-lfs. After installing, you should initialize Git LFS with the command git lfs install. For other distributions, you can download and install from the source from the releases page on the Git LFS GitHub repository. Now let's learn about basic Git LFS commands. The first command is git lfs track, which is used to specify which files or file patterns should be managed by Git LFS. For example, to track all Photoshop files, we can use the command git lfs track ***psd**. To track all files in a directory, we can use the command git lfs track *videos ***. Don't forget to commit the .git attributes file to save the tracking patterns. The second command is git lfs track, which is used to view all file patterns currently being tracked by Git LFS. The output will be like the listing of tracked patterns with the file and .git attributes. These patterns are stored in the .git attributes file. The third command is git lfs status, which is used to view the status of Git LFS files in your repository. The command Git LFS status shows LFS files that would be uploaded. The command Git LFS status -JSON gives a detailed status with file sizes. It helps identify which files will be managed by LFS before pushing. The fourth command is Git LFS ls-files, which is used to view all LFS files in your repository. The command Git LFS ls-files lists all LFS files. The command Git LFS ls-files-s lists files with size and status. This command shows which files are currently being managed by Git LFS. Now let's learn about advanced Git LFS commands. The first command is Git LFS fetch. It downloads LFS content for specific files. Use the command Git LFS fetch to fetch LFS content, and use the command Git LFS fetch =include *PSD to fetch for specific files. This is useful when working with partial clones or specific files. The second command is Git LFS prune. This command removes cached LFS files from local storage. Use the command Git LFS prune to remove old LFS files, and use the command Git LFS prune -dry-run verbose to verify what would be pruned. This helps to reclaim disk space by removing unused LFS objects. The third command is Git LFS migrate. This command converts existing files in repository history to use LFS. Use the command Git LFS migrate import *include *PSD to import files to LFS, and use the command Git LFS migrate import *include *zip $fixup to modify recent commits. Note that it requires Git -LFS migrate extension. Use with caution on shared repositories. The fourth command is Git LFS untrack. This command stops tracking specific files with Git LFS. Use the command Git LFS untrack *PSD to stop tracking a pattern, and use the command Git LFS track to check if a pattern is untracked. This removes the pattern from .git attributes but doesn't affect already committed files. Here are some Git LFS best practices. First, track the right files, which means to be selective about which files to track with Git LFS. Track binary files that change frequently, large media files like images, videos and audio, and dataset files and archives. Avoid tracking small text files or code. Second, maintain the .git attributes file by keeping your .git attributes file organized and committed. Always commit .git attributes first. Group related file patterns together. Add comments for clarity. Third, follow workflow integration to integrate Git LFS smoothly into your development workflow. Install Git LFS on all team members' machines, include LFS setup and onboarding documentation, use CI/CD systems that support Git LFS, consider partial clones for very large repositories. And fourth, watch out for storage quotas on hosting services, bandwidth limitations for large pushes and pulls, forgetting to track new binary file types, not running "Git LFS install" in new clones, and migrating existing repositories incorrectly. Let's explore some real-world use cases for Git LFS. The first use case is game development. Game projects contain numerous large assets that change frequently during development. Git LFS helps manage these assets efficiently, while keeping the repository size manageable. Some of the file types are 3D models, textures, audio, and Unity assets. The second use case is design projects. Design teams work with large source files that need version control. Git LFS allows designers to collaborate on projects without bloating the repository. Some of the file types are Photoshop files, Illustrator files, sketch files, and high-resolution images. The third use case is data science. Data scientists need to track datasets and model files alongside code. Git LFS provides a way to version these large files without compromising repository performance. Some of the file types are datasets, model files, Jupyter notebooks, and visualizations. The fourth use case is mobile app development. Mobile apps often include assets like images, videos, and compiled libraries. Git LFS helps manage these resources while keeping the code base lightweight. Some of the file types are app icons, marketing assets, video tutorials, and binary libraries. Let's summarize what we have learned so far. Git LFS solves the problem of storing and versioning large files in Git repositories. It replaces large files with text pointers while storing actual content on a remote server. It improves repository performance with faster clones and reduced storage requirements. It is simple to set up and integrates seamlessly with existing Git workflows. It is essential for projects with large binary files, media assets, or datasets. Thank you. Here are some Git LFS resources: official documentation, GitHub repository, Atlassian Git LFS tutorial, Git LFS on GitHub Docs, and Git LFS environment variables. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.